Welcome guys to today's tutorials. We'll be looking at IJMB 2023. I would like you to get your writing materials ready with your calculators. We'll be right back. So our question 1. Given that sine theta equals to 4 over 5, compute the values of tan theta minus cos theta. Now, if we have sine theta equals to 4 over 5, we are asked to find tan theta minus cos theta. Now, before we can do this, we'll first of all find out the values of tan theta and cos theta. Now, sine theta, we know that sine theta equals to opposite over adjacent. Sorry, opposite over hypotenuse, sine. That is our SOHCAHTOA. Applying our SOHCAHTOA rule. Sine is opposite and hypotenuse. Cos theta is adjacent all over hypotenuse. And tan theta is opposite over adjacent. Now, all these are applicable in a right-angled triangle. So if we have a right-angled triangle, and this is our theta, now the side facing your theta is referred to as your opposite. Now, the side bearing the 90 degrees and your theta is referred to as your adjacent. And the side facing the 90 degrees is referred to as your hypotenuse. Now, from here, from our question, we can see that sine theta is opposite over hypotenuse. Now, this, our opposite will be 4, and our hypotenuse will be 5. Now, applying our Pythagoras rule, which states that hypotenuse squared equals to opposite squared plus adjacent squared. We can find out what our adjacent would be. So this would be, since our hypotenuse is 5, 5 squared equals to opposite is 4 squared plus adjacent squared. Now, square of 5 is 25 equals to 16 plus adjacent squared. So our adjacent squared will give us 25 minus 16. And our adjacent squared will give us 9. So square root of 9, adjacent will become the square root of 9, which is 3. So our adjacent here will be 3. Now, applying to tan theta, which is opposite over adjacent, our opposite is 4 and adjacent is 3, and cos theta, which is adjacent over hypotenuse, our adjacent is 3 and our hypotenuse is 5. Now, to our question of tan theta minus cos theta. What is tan theta? 4 over 3 minus cos theta, 3 over 5. From here, we do what? We take LCM. 3 and 5, our LCM will be 15. Now, 3 into 15 will give us 5. This will be 4 times 5. If alpha and beta are the roots of the equation, 2x squared plus 3x plus 6 equals to 0. It says find alpha minus beta squared. Now, from our equation, this, our A is 2, our B is 3, and our C is 6. Now, we know that alpha plus beta equals to minus B over A, which is minus 3 over 2, and alpha beta, which is C over A, equals to 6 over 2, which will give us 3. But now what we are looking for is alpha minus beta all squared. So if we have alpha minus beta all squared, we are going to have alpha plus beta squared minus 4 alpha beta. Now, if we have this, we can now apply these laws into this. Now, our alpha plus beta will give us minus 3 over 2 squared minus 4 times 3. Now, this will give us 9 over 4 minus 12 over 1. Now, if we take LCM, our LCM here will be 4 all over 9 minus 4 times 12 will give us 4 into 4 will give us 1. 1 times 9 will be 9. 1 into 4 is 4. 4 times 12 will give us 48. So 9 minus 48 will give us 39 minus 39 over 4. So minus 39 over 4 will be our result for alpha minus beta all squared. If x and y are positive integers such that x plus xy plus y equals to 54, find x plus y. Now, they say we should find the value of x plus y. For us to find the value of x plus y, we have to find the value of x and y. Now, we know that we have x plus xy plus y equals to 54. But now we can't factorize this out. So we'll look for a common neutral term to use in factorizing this. So for us to factorize this out on a neutral term, we can say add 1 to both sides. This one is acting as a catalyst in factorizing this. So this will become x plus xy plus y plus 1 equals to 54 plus 1. Okay, so if we now group this and group this together, we can now bring out the common term here, which is x plus x bracket 1 plus y. And if we bring out this common term here, we have it as 1 bracket 1 plus y equals to 4 plus 51 plus 1 will give us 55. So this becomes x plus y, x plus 1, x plus 1 and 1 plus y or y plus 1, whichever way, okay, equals to 55. All right, now from here we can say, from here let's factorize, let's neutralize this out. This becomes x plus 1 plus, let me confirm this. From here we look for the factors of 55. Now factors of 55 are 1 and 55 or 5 and 11. Now if we put these factors in here, we will set this to be x plus 1 equals to 5, then y plus 1 equals to 11, or using these factors, or x plus 1 equals to 11 and y plus 1 equals to 5. Now, if we go for x plus 1 equals to 5. X is going to be 5 minus 1, which is 4, and y plus 1 equals to 11, y equals to 11 minus 1, which is 10. Going for these factors, we are seeing that x plus 1 equals 11 will give us x equals to 11 minus 1, which will give us 10. And y plus 1 equals to 5 will give us y equals to 5 minus 1, which is 4. So the values of our x could be either 10 or 4, while y is either 4 or 10. This simply means that when x is 10, y is 4. And when y is 4, x is 10. So if we have x plus y, which will become x is 10. When x is 10, y is 4. This will become 10 plus 4, which is 14. And when x is 4, y is 10, is still 4 plus 10, which is 14. So either way, the value of x and y are either 10 or 4 or 10. Solve the equation 6 sine squared x plus cos x minus 5 equals to 0. Please, this is 6 sine squared x, not sine 2x. All right, if we have 6 sine squared x plus cos x minus 5 equals to 0. Now, we know that sine squared x equals to 1 minus cos squared x. Okay, so replacing sine squared x with this, we are having 6 bracket 1 minus cos squared x plus cos x minus 5 equals to 0. So opening up this bracket, 6 times 1, 6 minus 6 cos squared x plus cos x minus 5 equals to 0. So 6 minus 5 will give us 1. We would have minus 6 cos squared x plus cos x plus 1 equals to 0. Now we multiply this equation all through by a negative to eliminate this negative sign. So this becomes 6 cos squared x minus cos x minus 1 equals to 0. Now let's say let cos squared x, let cos x equals to y. So this becomes 6y squared minus y minus 1 equals to 0. Now this forms a quadratic equation for us. Now for us to solve this, we know our a equals to 6, b equals to minus 1, and c equals to minus 1. So let's use our almighty formula or quadratic formula, which says that minus b plus minus root b squared minus 4ac all over 2a. Okay, now where our b is minus 1, this becomes minus 1 minus minus 1 plus minus 1 squared minus 4 times our a is 6 times our c is minus 1 all over 2 times our a, which is 6. So this becomes minus times minus will give us plus. This becomes 1 plus minus root 1. This times this will become plus. 4 times 6 will be 24. All over 6 times 2, 12. So this becomes 1 plus minus root 25 all over 12. And we know that root 25 is 5. So this is 1 plus minus 5 all over 12. So our first value will become 1 plus 5 over 12, or 1 minus 5 over 12. 1 plus 5 will give us 6 over 12, or minus 4 over 12. So if we break this down, this gives us 1 over 2, or minus 1 over 3. Now, we know that our value of y are this. So this becomes back to our question that says y, our cos y will become cos y equals to half. Okay, since we say let y, our cos x equals to y, so cos x will become 1 over 2 or minus 1 over 3. In order to find the value of this becomes x equals to cos inverse of half, or x equals to cos inverse of minus 1 over 3. And we know that half is something as 0.5. So if we do the cos inverse of that, we are having cos inverse, our shift cos, and of 0.5 will give us 60 degrees. And if we do this is something as 0. minus 0.1 minus 0.33, which will give us shift cos inverse of 0.33 minus 0.33 will give us 109.26. So the values of this will become 109.26 or 60 degrees, which is within the range of what we're given, that our values of x should be between 0 and 360. Find the set of values for x which 7 raised power x plus 8 is equal to 8 raised power x plus 7. Now we are going to apply our logarithm law here, which says that x plus 8 log 7 equals to x plus 7 log 8. Yeah. So expanding this, we are having x log 7 plus x log 8, plus 8 log 7 plus 8 log 7 equals to x log 8 plus 7 log 8. Now, you can see on both sides we are having x log and x log. So we bring them together. If we bring them together, this becomes x log 7. Okay, let me try to keep it positive. This becomes 8 log 7 minus 7 log 8 equals to x log 8 minus x log 7. Now, here we have our common terms, which will give us x bracket log 8 minus log 7 equals to 8 log 7 minus 7 log 8. Okay, now we can since we are looking for the value of x, we can divide both sides by log 8 minus log 7. So we have x log 8 minus log 7 all over log 8 minus log 7 equals to 8 log 7 minus 7 log 8 all over log 8 minus log 7. So this cancels out, leaving us with x equals to 8. Our log 7 would give us log 7 log 7 equals to 0.8451, and our log 8 equals to 0.9031. Now, using these values here, this becomes 8 times 0.8451 minus 7 times 0.9031 all over 0.9031 minus 0.8451. Now, if we calculate that, we have 8 times 0.8451, which is going to give us 6.7608 minus 7 times 0.9031. That will give us 6.3217 all over 0.9031 minus 0.8451, which will give us 0.058. All right, from here we solve this, which is 6.7608 minus 6.3217. This will give us 0.4391 divided by 0.058. Now, our x equals to our answer divided by 0.058, which is 7.57. That's the value of x. If you've watched up to this point, please like and subscribe to our channel. Now, question 6. Given that A equals to our matrix A is 1, 3, 1, 0, 2, 0, and 1, 4, 3. And the matrix B is 2, 0, 1, minus 1, and 3, 4, 5, minus 1, 0, 6. Now, it says show that A, B transpose is equal to B transpose times A transpose. Now, first off, we are going to calculate what's our A and B. So if we have AB, that simply means multiply matrix A by matrix B. And in doing that, we are going to have, in multiplication of matrix, we are having our row. This is referred to your row, and this is referred to as column. So we have column 1, we have column 2, we have column 3. We have row 1, row 2, and row 3. Same thing with our B matrix. We have row 1, row 2, and row 3. Column 1, column 2, and column 3. So in multiplication of A and B, it will be our row 1 against column 1. Row 1 against column 1. Row 1 against column 2. Row 1 against column 3. Then we'll go to the next stage. Row 2 against column 1. Row 2 against column 2. Row 2 against column 3. Then we have the third stage. Row 3 against column 1. Row 3 against column 2. And row 3 against column 3. So now let's go into it. We have A, B, which is row 1, our first row. We have 1 times 2 plus 3 times 3 plus 1 times minus 1. That is for our first row and column. When you've done your first column, first row against your first column, second row, first column, first row against second column, and first row against third column. Now you also do your second column, your second row, first column. So your calculation should be first row, first column, first row, first column. Now first row, second column, first row, third column. Now you have your second row, first column, second row, second column, and second row, third column. Now the third one will become your first row and your third row, first column, third row, second column, and third row, third column. Now this, when you have this, will result to something. Your result should be something like this. So at the end of the day, you'll find out that when you're transposing AB transpose will now be giving you your diagonals will remain constant. Your diagonals will remain constant 10, 8, and 37. Now, first row will turn to column and your first column will go to row. So if we move this here, this becomes 6 and 11, while this becomes 12 and 20. Then we'll swap these two to be 16 and 10. Now, this is your AB transpose. All right. So after having our AB transpose as this, we still need to find our B transpose and A transpose. Now, remember how we got our transpose from this to this. So for B transpose, now we look at our matrix B. Our diagonal will keep constant 2, 4, 6. Then change our column to rows, which becomes 3 and minus 1, and our rows to columns, which becomes 0 and minus 1. Now we interchange the two remaining digits, we interchange as 5 and 0. Now this is our B transpose. Now let's look at transposing A. Same thing. We keep our diagonals constant 1, 2, 3. Change our columns to row, which becomes 0 and 1. Change our rows to columns, which becomes 3 and 1. Now interchange 0 and 4. 4 and 0. Now this is our B transpose, A transpose. Now from the question, it says AB transpose is equal to B transpose, A transpose. So we are going to multiply our B transpose against our A transpose. And in doing that, we'll still be applying this rule where we have our 2 times, which this is our first rule against first column, 2 times 1 plus 3 times 3 plus 2 plus minus 1 times our 1. So if we do this, let me just show you an example of this. If we do this, this becomes 2 plus 9 plus, okay, minus 1 times 1 will give us minus 1. So 11, 9 plus 2, 11 minus 1 will give us 10. So our answer for this first one will become 10. At the end of the day, if you finish transposing all this, if you finish your multiplication using this here, you will now find out that you are having your B transpose times A transpose as 10, 6, 11, 12, 8, 16, and 20, 10, 37, which satisfies this, that our AB transpose is equal to our BT transpose times A transpose.
Hi, if you have not subscribed to this channel, you can do so in 5 seconds. 5, 4, 3, 2, 1. And don't forget to hit the notification button.